So next topic we discuss about the cladding and design requirement. It's not about only for the glass. We just kind of think about how you can designing about the cladding. What is about the main consideration? The primary consideration of your cladding, you have to be consider about the keeping water out. I think this is the most important for your facade, for your envelope design. You have to prevent the water leakage from the rain, snow, ice. The water problem are more issues in the tall building. So means you have to be proper detail between the structure and the glazing. So how you can design the waterproofing, how you can using some sealant, how you can use the waterproofing membrane there. So we talk about this all different the detail on 445 because it has to be understanding or complicate different detail system first, and then you can understanding about the waterproofing after this. I think this is one of the most difficult the detail to designing about the window detail with some structure member. So we talk about this one in a detail on the 445 class. Okay, you can just waiting for the 445 class. Also, you have to be understanding to design the preventing air leakage. The prevent unintended passage of the air between the indoor and outdoor. Air leaks waste contributed air. So it means you have to be concerned about how you can make an air tightness. So usually the window frame and concrete slab having the gap between, right? So it means how you can make the tightness between these two part. How you can conceal this joint well. So we talk about this air tightness, air leakage, the detail on the 445 when I talk about the waterproofing, to design the window detail. Okay. So the primary function of the cladding, controlling light. It is control sunlight to balance between useful illumination and unnecessary effects such as glare and fading of a material. So you can use in some treated glass as we discussed. You can consider about the block the sun during the summer but still getting the winter sun. So you can use the gradation, the laminate glass with the treated glass. Also, simple way, you simply having the sun shading device like a curtain and blind. You can just actually control the light. Next one is controlling the radiation of heat. The interior surface can cause discomfort due to radiant heat transfer in the summer. So it means, as we talk about, you have to be protect summer radiant heat, but still getting the winter radiant heat. So to control this system, you can just control by the sun shading device, or you can just do the laminate or treated glass. Okay, so you have several different options to designing about the space. Also, the ventilation. You can your glass can vent it, so it means you can also control the sun radiation of heat. So next one is controlling conduction of heat. So conduction of heat. Heat conduction is the heat movement between the material having the different temperature. So it means glass, if you're using the aluminum glass frame, it is good conductible material. It is always kind of transfer heat energy from outside to inside, inside to the outside. From this region, it will much better to use in the thermal broken window. We talk about it later. But thermal broken window, you simply broken on some inside and outside frame, and in between you can use in the rubber gasket. Rubber gasket help to protect this thermal transfer because rubber is low conductivity material. So we talk about this one later. And then controlling sound. Double glazing system, usually insulation factor between the two glasses. So means you can actually control the sound, okay, when you just consider the double glazing system. So I think this is also main function of the glazing. The next secondary function of cladding, you need to consider the window pulses, especially when you design high-rise building. There's a different the window pressure. So means the window subcontractor usually analyze this window pressure and to design the window proper way. So means they probably designing a different window frame size, or they provide a different glass type. So this is basically from the wind forces, because wind forces always the different depending on the location, depending on the height. So that's why it have to be analyzed from the window subcontractor to design. And then also you have to be controlling the water vapor. The water vapor is occurred by possible condensation. So it means water vapor relating to the moisture transfer. Moisture is moving from the some inside to the outside, outside to inside. It can cause the loss of insulation value, the metal corrosion, and wood decay. You probably remember about this diagram. You remember dew point, right? We talked about this one from the last semester. You have to remember air always moving from higher temperature to the lower temperature, because higher temperature is more vapor. It's simply understanding during the summertime it's higher temperature. Usually it's more humid, but during the winter time lower temperature usually dried. So that's why higher temperature is more vapor, lower temperature less vapor. So it means vapor always moving from the more vapor to the lower vapor, because it usually making the balance between. So it means cold climate condition inside always higher temperature, of course. So that's why more vapor inside, less vapor outside. So it means vapor always from the inside to the outside. From this region, when you design the cladding, your vapor barrier always locating in the inside, right? You remember we talked about this one lots of time from the last semester. And then during the hot climate, hyper barrier is outside, which is a more higher temperature outside, and then lower temperature inside in a hot climate condition. So it means more vapor outside, less vapor inside. So it means vapor actually moving from the outside to the inside. From this region, you have to be design the vapor barrier outside to protect the moisture transfer from the outside to the inside. What about the neutral zone, moderate climate condition? So it means similar vapor outside, inside. I mean, you don't need any vapor barrier in this location. So also here we learned about the geographic map about this moderate climate zone or hot climate zone or cold climate zone. So you can choose the vapor barrier method basically from this map. Probably if you don't know about some idea and don't know about this issue and this content, you probably just open the 346 class. So I already covered for the one lecture to talk about the condensation, talk about the moisture transfer, and talk about the dew point, and talk about the map. I think you can just find out this information from the 346 and 546 class. Next one is secondary function of cladding is also considered about the movement. The movement can happening from the thermal expansion and contraction, moisture expansion and contraction. Okay, so thermal expansion and contraction. It is caused by change in the temperature. This movement can affect curtain wall, frame, or window frame. Moisture, same thing. Brick, stone, concrete, wood material change dimension due to the moisture content. So means thermal movement and the moisture movement. So this is usually the material can become bigger and smaller. I mean, expanding and shrink. So means this simply understanding about this table, like this diagram. When expanding it, you keep pushing it. So that's why your cladding keep impacting. And then also between the cladding and the slab edge, you can have some gap between because about this keep pushing and shrinking, and then it's making out of this kind of a joint and gap between. So that's why when you make the bigger gap, because about the movement, it has lots of airflow. It means you're losing the loss of heat energy. Also having the moisture transfer, making the condensation issue. Also air tightness and also water issue. So that's why you have to be very concerned about the movement. It means when you're designing about your connection between the window or cladding and the structural member, we always have to be provide flexible space, which is a tolerance space, because we have to be concerned about always the cladding have to be moving up and down or left and right, depending on this thermal or moisture or structural movement. Okay. For the cladding design, we also consider structural movement. Architects consider the building foundation, column shortening, which is typically occurred in a high-rise building. So means when you're making the shortening or making out the lateral forces like a wind or earthquake, this is all impacted your cladding design because about this related to the movement. This is the same as the thermal expansion and moisture expansion and contraction. So all this kind of movement always impact to the cladding design because it keep pushing, and then when you keep pushing, sometimes the cladding is broken, the cracking. The mostly important thing is when you keep pushing it, so gap between the cladding and the joint keep making the bigger and bigger. So it means when you're making the bigger and then making the air gap, so actually water coming in, also moisture transfer, and then also lots of a different issue between the cladding and this structure system. Okay, so that's why you can just find out when movement keep happening, you can just see the broken glass, the buckled cladding, which is buckled cladding is like that, and then sealant failure because about the between the glass and the structure, this keep wider and then making the bigger opening, and then broken cladding attachment failure of the whole wall. So that's why, so when you're designing about the glass, you have to be considerate about the movement. So it means you have to be provide the tolerance space between the structure member and the window, or structure member and your exterior cladding. We always have to provide this tolerance space, certain tolerance space, because you have to be receive the energy from the lateral forces or the vertical forces. Okay. Now I discuss about the water tightness in cladding. Even when you're just designing the cladding, how you can protect the water from outside. So water is the major concern about the water penetration. We need to consider opening. Like we need to consider about the opening here. Opening can be eliminated by carefully sealed every possible joint. You can just simply joint. You can just protect the water penetration. And you have to be consider the forces are always present, such as gravity, wind forces, capillary action. These forces keep delivering water from outside to the inside. So mean to designing about your cladding joint, you have to be understanding about the forces. Okay, to protect the forces, we need the proper weather barrier over the sheeting. So let's look at the possible forces type on your building and show how we can protect the water from the outside. The first one is gravity. You remember the gravity always from the top to bottom. So means when you're designing about the cladding like this way, when you're designing cladding this way, which one is correct? This is outside. So of course this is correct on the right side, because when you're just designing this one, always kind of the gravity, water keep down, and then when you just kind of inside is lower, this water keep moving into the assemblage. But when you're just designing this way, when water coming in, water never coming up, right? Because about the gravity, water keep coming down from the exterior. It's never coming into the assemblage. Next one is momentum. The momentum is the refracting forces. So when this water touch the flat surface, the always kind of water refracting. So means when you designing about this flat edge for your cladding, water always coming into your assemblage because of the momentum forces. To protect this momentum forces to delivering the water from the outside, you can consider about this labyrinth joint. You can make out this small dam and more about the labyrinth joint, that they can just kind of touching it, and then they protect the water from the refraction. So this is considered about the momentum forces to design the cladding. Next one is consider about the surface tension. So water tends to staying over the surface. So means water keeps staying over the surface and then keep coming under the surface, and then it just drop into the assemblage. Okay, so this is a exterior sheathing and this is airspace, but these types of the cladding system keep water the driving into the assemblage. So from this region, to protect the surface tension, you have to be design the water stop here. This is a water stop, simply tensioning the dislocation. Then they cannot coming into the space because about the water stop here. They simply making the water stop and the water coming down, and then also gravity is not this way, and then more about the outside is lower, and then this water keep coming out. Okay. So means we have a lot of different forces to designing, to consider about to design your the cladding. So you have to be provide these types of the detail when you design the cladding system. Next one is capillary action. What is capillary action? Usually air really lacking about the narrower space. So means this is a much higher air. It means air keep pushing into this lower space. Okay? So because the air is not coming into this space because this is solid and solid, it has only one small gap air can find the passing through. That's why all huge amount of air keep pushing into the narrow area. So means water keep delivering into this assemblage location. So that's why in this case you have to be designing the counteracting space. So I can just kind of different color, I can use it. You can see here, this is a counteracting space. So means you can just make it a bigger space, little bit bigger space for the cladding. So means air keep pushing in from the outside to the inside. Also another air just fighting from the inside to the outside. Because about that this is air space, air pocket here. So that's why they just fight each other to making out some balance between outside and inside. So that's why air not coming into your space. Similar way, so you can use this pressure equalization chamber inside. So in this case, you can see air always moving, airflow, wind is already flowing from outside to inside, water always delivering from the outside to the inside. In this case, you can just make this pressure equalized chamber, which is we call that the PEC. You can just make another air pocket here. This is air counteracting forces from the inside to the outside, from this box. Okay, so mean from the outside inside, they keep pushing the air, but also keep pushing the air from the inside of the pressure equalized chamber, and they just fight each other to making the balance out. So means water not coming into the space. So now we talk about the RAINSCREEN system. We already discussed about the RAINSCREEN system before. This is a possible RAINSCREEN system. I just kind of introducing about this system because most cladding system doesn't use the sealant and backer load between the panel. So not gonna using the sealant because it's not a good looking. Also it's too much work. So means they just kind of more about the dry stacking method, dry assemblage method, panel and panel, and then simply assemble over this channel. Okay, but you remember about when you don't have any sealant, you have to be consider about the different forces. So in this case, they're using you can consider to use the two different forces for your panel joint. First one, panel to panel, you can consider using this leverance joint. So you can see this leverance joint is interesting to apply all different forces factor. So first one, they have this is inside is higher, lower. It means the water coming in because of the gravity, they keep water out from here. And then also moment forces, the water touching it, they usually coming inside, but they're making a small dam, which is a leverance joint. Water never coming into the space. Also the tension, surface tension, usually water staying in the surface. That's why we provide the water stop. But here the water stop to this location, water never coming into the space. So means when you're designing about these types about the joint, it consider all different forces to making out the proper and optimize the joint. And also next type is simply designing this PEC, which is the pressure equalized chamber. The pressure equalized chamber locating the vertically and horizontally. This one is holding the panel and panel. So it means this is a panel and panel. So it means you remember about the water tended to coming from outside to the inside, because air was from the moving from the higher amount of the air to the lower amount of the air. So that's why you have to be making out the counteracting forces from this PEC. The air always kind of moving from the inside to the outside. They just kind of fight each other. So that's why they always making the balance outside. Okay, so it means the air is never coming into this system. Okay, so in a RAINSCREEN system, you have to be remember the one thing as well. So just designing the space, you provide 1 inch to 2 inch gap between the finished cladding and the sheeting, which is the finished material, because you have to provide the space, which is airspace, to dry out the water. Even we designed it very well to protect the water flowing from the outside inside using these two different methods, but still the water is very small particle. That's why they're still coming into the assemblage. But when your water coming into this surface, you have to be dried out this water as much as possible. Okay, the last things I just kind of bring it out the video. To protect the water, we have to be consider lots of elements such as the joint type, waterproofing membrane, and cladding type. So this video is very well representing about the RAINSCREEN design. Also, when you just think about the RAINSCREEN spacing, we talk about the air space 1 inch to the 2 inch, but you also can designing the drainage mat between the cladding and the sheeting outside. The drainage mat is also pretty similar working as the airspace. So this video, they use the drainage mat instead of using the airspace. So let's look at how it works. Okay.
When it comes to designing high-performance buildings, you must be adamant about moisture control. Waterway, RAINSCREEN, and ventilation mats give your wall systems countless performance advantages. Advantage 1. Drainage. Waterway RAINSCREEN is installed between your building and its exterior cladding. It features an advanced filter fabric and polypropylene drainage core. Waterway creates a capillary break and space for water drainage, allowing it to mitigate moisture penetration. Advantage 2. Ventilation. Our RAINSCREENs also provide continuous ventilation by convection or stack effect. As the wall heats up, warm moist air rises and escapes out the top, while cool dry air is introduced at the bottom. This cyclic ventilation dissipates moisture, keeping your building dry. Advantage 3. Open drainage path. Chambered configurations like the furred wall shown on the left can only provide drainage and ventilation within a confined space. Waterway's 95% open area ensures a clear space for multi-directional drainage and drying. Advantage 4. Moisture protection. Our unique filter fabric functions like an extra layer of house wrap. It is fully tested to prevent water penetration from the outside, keeping your building dry on the inside. Advantage 5. Backside drying. The perm rating of our fabric exceeds 200. This means it promotes the backside drying of your exterior materials. Moisture in the facade is allowed to evaporate through the filter fabric, allowing the wall to dry from the inside. Advantage number 6. Flat walls. Typical RAINSCREEN products are not able to resist point loads from siding attachment, resulting in a wavy siding surface. Waterway's robust fabric distributes point load during siding attachment, resulting in a flat, uniform surface. Advantage number 7. Retained space. All RAINSCREEN products look like they're providing a consistent drainage space behind the claddings. The truth is they cannot hold up to the normal stresses from siding installations. Once nails, screws, or other forces are applied, they compress substantially, compromising the drainage space. The advanced geometric configuration of our polypropylene core results in the industry's most rigid material. This ensures the drainage space is maintained across your wall. Advantage number 8. Uniform thickness. Waterway contributes to uniform thickness in your scratch and brown coats, unlike furred or strapping systems. Variations in stucco thickness can often result in very thin areas which are prone to vertical cracking. This is never the case with Waterway. Advantage number 9. Cushion. While on the topic of stucco, Waterway's flexible core also functions as a cushion between your building and exterior facade, reducing stress due to thermal movement or settlement. Waterway is proven to reduce cracking in stucco and stone veneer systems. Advantage number 10. Validation. The Building Research Association of New Zealand conducted an 8-year study on numerous RAINSCREEN materials and configurations. Only the Waterway product passed the established criteria. Copies of this report are available upon request. After 15 years and 40 million feet, no one offers a better performing RAINSCREEN mat. For additional information, call us at 1-800-305-1045 or visit us on the web at stuccoflex.com.
Okay, I think so you're just kind of learning about what is about the benefit to using this material. Okay, so I think this is the last slide to show here. I just kind of bring this image because kind of you have to be very concerned about the designing about your detail. This one is in the Berkeley campus, and then the balcony actually collapsed and failed, and 6 students died after falling down from the 5th floor balcony. Because about they intended to design it, and this of course not for the 6 people, right? This is not over the occupancy level. So that's why it's kind of one main reason, but also this structure is getting weaker because usually when you see these types about the beam, mostly this is exposed. So that's why when this wet, it's very easy to dry it out. But when you see this detail, so this is everything captured by the finished material. So it means when water coming in, the water never getting out of the space. So that's why even that it doesn't have any kind of air space between the structure and the finished material. So you remember the RAINSCREEN system. Of course, it's a little bit different as the RAINSCREEN system. But always have to be concerned about the ventilating the air, which is to dry out the water as much as possible. But in this case, everything just very tightly water capturing into the space, and then keep moisturing, and then keep affecting this structure, and then it means water keep impacted the moisture impacted this structure, the structure member getting weaker. So that's why the getting weaker, and then this structure member is weaker, and then 6 people standing over it, and then this balcony simply collapsed and then failed. So that's why, so when you're designing about the space, when you're designing about any kind of a architectural project, you have to be concerned about the safety. So it means you have to be considering about the detail. If you fail the detail, so you can make this kind of happening, right? So that's why it's also aesthetic part is important, but also you have to be concerned about the safety part, and then more about the practical part, how you can design the safe building. Okay, thank you for today, and then we just more to talk about the window type and the another cladding design on Thursday. Thanks.